Alright, now we're on the natural logarithms. Okay, and if you don't remember what a natural logarithm is, it's this right here, natural log of x. It was in algebra, and what do you know? It's back. It's back for some more in Cal 2. So, what we're also going to be going over is the derivatives of the natural log. Alright, so this is the rule or the definition of a derivative of a natural log. It states that the derivative of natural log of u is 1 over u du over dx, and it says when u is greater than 0. Now, you're probably wondering, okay, what does that even mean? Well, basically, whenever we have natural log of x, so for example, since we have this right here, the derivative of the natural log of x would be 1 over x, because our u in this case is x, so it would be 1 over x, and then the derivative of the x, which would just be 1, right? So it would end up having 1 over x as the derivative for this one, and of course it says u is greater than 0. Pretty much anytime you see a problem, it's always going to have a value that's here that's going to be greater than 0. If it doesn't, then it just wouldn't make sense. It wouldn't be a real natural logarithm. It wouldn't, because you can't have negative values or 0 in a natural log. Okay, so just remember those little key facts. But since we went over that, let's go ahead and try some problems so you can kind of see what I mean by all this in action. So I have 3 problems set out. Number 1 is the real basic one, then you step it up a little bit, and then we step it up a little more with number 3. Okay? So let's start with number 1. Y is equal to natural log of 3x. Okay? And it says find the derivative of it. Okay? So we're going to apply what we just took a look at with the basically the formula of the derivative of the natural log. So we have natural log of 3x, right? And we want to find the derivative of this. So the derivative of this would be dy over dx, right? Because we're taking the derivative with respect to x, and this is y, so we're taking the derivative with y with respect to x. So if we do that, we end up having, remember, it's 1 over u, and what's our u? Our u is a 3x, right? So 1 over 3x, and then it says du with respect to x, right? Just because we're using x in this case. So the derivative of 3x, so what is the derivative of 3x? It would be 3, right? So 3 would come right here. So we have times 3, and what happens if you have a 3 over a 3? They end up going away, right? We end up, it makes 1, so you end up left with 1 over x, okay? And that was basically the derivative, that was the derivative of natural log of 3x. That's how we worked that one out, okay? Now, let's go ahead and move on to the next one. Okay, so we did number 1, right? And let's do number 2, right? So number 2 says y is equal to the x fourth over 4 natural log of x minus x to the 4 over 16. So looks like a lot to do, right? Looks like a whole bunch of crazy steps that it's going to be real hard, but let's go ahead and try it out so we can be the judge of that ourselves. So it was y is equal to x to the 4th over 4 natural log of x minus x to the 4th over 16. Right. So the first thing that we should notice, or we should see, is we have a product of variables, right? Product of variables. So if we took the derivative of this, that's going to give us a hint that we're going to use the product rule from Calculus 1. So anytime you have variables multiplied together and you're taking the derivative, you're going to use the product rule. And let's go ahead and work it out. When we do that, that's basically, I'm going to go ahead and take the derivative of one of them and leave the other alone, and then plus that other one that we left alone, we're going to take the derivative of that one and then leave the other one alone. So I'm going to go ahead and do this one first. I'm going to take the derivative of this first and then leave the natural log of x by itself. So if I do that, the power rule, right, the 4 will come down. So you'd have 4 x to the 4th, or x to the cube, my fault, because you subtract 1, x cubed, over 4, and then we leave the other one alone, right, the natural log of x. Okay, now we say plus, and now we're going to take the derivative of the natural log and leave this one alone. So if we took the derivative of natural log of x, this would be 1 over x, right, and then times the x to the 4th over 4, and then we got to take the derivative of this last part right here, right? So if we took the derivative, we use the power rule again, the 4 would come down, and then we subtract 1 from the power. So what that would look like would be minus 4x to the 3rd over 16. And so what makes up 16? We got to ask ourselves, 4, right? Because we could reduce that. It's 4 times 4, so 4 over 4, boom, those guys are gone. And then let's go ahead and clean this up a little bit, because it seems a little crazy. And also over here we notice the 4 and the 4 will go away, right? So we have x cubed natural log of x, and then right here x to the 4 over x. This one, we'd lose 1 here, right? This will go away. This will become a cube now. So we'd have a plus x cubed over 4, and then minus, since this was reduced, we have a minus x cubed over 4, right? And we notice right here, we want to combine like terms if we can. These just so happen to be the same but opposite signs. So that would mean they would go away, eliminate each other. So we'd be left with x cubed natural log of x. And that would be our answer for number 2. Okay, that was number 2. So we did number 1, we did number 2, and now let's try number 3. Okay, number 3 says y is equal to natural log of secant of natural log of theta. And like I said, for number 2, it wasn't that bad. You know, don't be scared. It might seem bad at first, but you know, try to work it out and actually see for yourself. And a lot of times, it's really not that bad. But anyways, number 3, let's go ahead and work on that one. So we have y is equal to the natural log of secant natural log of theta. Now, this might look a little funky right now, but basically what this is saying is that the secant natural log of theta is all inside the natural log. Okay, so we have a natural log, and then secant, and then of the secant there's a natural log of theta inside there. So it looks a little weird, but I'll show you how to work this one out. Okay, so we're going to take the derivative again. So with respect to, and what is this going to be with respect to now? See, the previous ones were with respect to x, right? Because we had x in our variables. Now this one has what? Theta. So we're going to derive with respect to theta. Now, we got to remember that the derivative of natural log again is 1 over our u. Our u is this now. So we're going to have 1 over secant natural log of theta, right? And then also times the derivative of u. Our u is the secant natural log of theta. So what's the derivative of secant? It's secant tangent, right? So secant, we're going to have multiplied by a secant natural log of theta tangent natural log of theta. Okay? And then what's the derivative of natural? Because what we got here is we got a chain rule, right? Because we still have to take the derivative of the inside of this, because it's the derivative of u with respect to theta in this case. Our u is secant natural log of theta. So we have another variable right here. Or this is theta. So we got to take the derivative of the inside of this. The derivative of the inside would be 1 over theta, right? Because the derivative of natural log of theta would be 1 over theta. So times, and then we got 1 over theta. Alright, so let's go ahead and clean this up a little bit. So the secant natural log of tangent theta, tangent natural log of theta, this will be on top, right? And then this theta is being multiplied by the secant natural log of theta on the bottom. So if we rewrite it, we're going to write the secant natural log of theta tangent natural log of theta, and then over, and I'll go ahead and put the theta first, theta secant natural log of theta. And so what do we notice here? These are being multiplied, right? Both the top and the bottom by a secant natural log of theta. So since they're being multiplied by that, and we have this secant natural log of theta over this secant natural log of theta, that means they would go away, and we'd just be left with the tangent natural log of theta and the theta. And that would be pretty much, that'd be it. That's our answer right there. Okay, so really wasn't that bad. The key here is to look at them individually, one step at a time. If you look at it as this one whole thing, it could get to be a bit much. It might make you feel like, oh man, this is crazy, this is hard, I'm never gonna get this, but it's really not that bad. You just got to break it down step by step. Okay, I hope that helps. I'll see you in the next video.